Find the complete integral of this equation. Now because I need to change this equation into the format f capital PQ to be equal to 1. For that I need to consider what is capital P and what is capital Q. I need to choose this. For that we have 3 formats. Just remember them and then solve your question. First one, if you consider 3 variables u, v and w to be log x, log y, log z respectively, then your small p will be equal to, you know that it is del z by del x, right? You have to take the chain rule like this, del z by del w, then del w by del u and then del u by del x. You have to go from z to w and then w to u and then back u to x. Because what is p? It is the partial derivative of z with respect to x. So start from z to w, w to u and then u to x. The value of u is dependent upon x, right? So we have to end up with del u by del x. Similarly, what is q? That will be del z by del y, we know this. So take this as again del z by del w into del w by del v, from w to v and then from v to y, then del v by del y, right? Okay, so in this case you can solve this, but you cannot solve this, right? So take your capital P to be this and capital Q to be this. The derivative which is unable to solve, take that derivative. The partial derivatives which are not able to solve, take those partial derivatives to be your capital P and capital Q, right? Okay. If you consider your u and v as x plus y and xy, then you have to take p to be, we know that it is del z by del x, then this is equal to del z by del u, then del u by del x, plus del z by del v, then del v by del x. You have to consider both these variables in the partial derivatives. Similarly for q, it is del z by del y, so then write this as del z by del u, then del u by del y multiplied, plus del z by del v, then del v by del y, which is multiplied. You have to remember this, right? Okay, this can be solved, this cannot be solved, this can be solved, and this cannot be solved. So for when you consider u, so take this as your capital P and take this as your capital Q. Please remember, capital P always dependent upon small u, capital Q will be dependent upon v, right? Take accordingly that. Next, if you consider in the third format, if you consider u to be the only function of x that is in square and v to be y square, then your small p will be del z by del x, definitely, but this can be written as, it is enough to write del z by del u and del u by del x multiplied. There is no need to write further del z by del v, then del v by del x. No. Why? Because u is depending upon x only, right? So there is no need to take this. This is solvable, this cannot be solvable, take this as your capital P. Similarly in Q, this is solvable, this cannot be solvable, take this as your Q, capital Q, right? So this is how we need to consider these formats, and accordingly we need to solve the question. Now coming back to the question, we are having this equation. What to do now? What you consider to be your u and v? Please guess. I cannot take u, v, w to be log x, log y, log w. That is not needed because I am having only x and y over here. So it's better to consider u to be the sum of x and y and v to be the product of x, y. When you consider the sum and taking that to be u, consider v to be the product of those, right? अगर आपको सम लेना है u x plus y का, तो v को आपको प्रोडक्ट की फॉर्म में लेना है, ये फॉर्मेट आपको लर्न करके रखना है. प्लीज रिमेंबर दिस फॉर्मेट. So let's move on to the solution now. This is the equation, and for this equation I am considering u to be x plus y and v to be xy, and I know that small p is del z by del x, and I have to take this to be equal to, I'm having the sum as u to be x plus y, so writing this as del z by del u and del u by del x plus del z by del v and del v by del x. Solving this further, okay, del z by del u cannot be solved. I'm taking this as capital P. What is del u by del x? It is 1, right? Similarly, del z by del v cannot be solved. I'm taking this as capital Q, and del v by del x is y. So it is changed into p plus qy, right? Similarly, small q, okay, this is del z by del y, del z by del u into del u by del y plus del z by del v into del v by del y. Please remember, q is having the partial derivative of z with respect to y, so consider y here. So this is equal to, this is your capital P, derivating u with respect to y, we get 1, it is 1, plus this is your capital Q, derivating v with respect to y, it is x. So it is p plus qx. Let me substitute the value of p and q now in this given equation. Okay, so this is x minus y, this is cancelled out. We have here px minus py equals to, this p cancelled out with this, and we have q into y minus q into x whole square. So x minus y, taking p outside, here also I'm getting x minus y equals to, if I take q outside, it is q square, and I can write this as x minus y whole square also. So these cancelled out, and we have p equal to q square. That's it. So our equation becomes p minus q square equal to 0. This is our standard form 1, that is fpq to be equal to 0. Now for this we always take capital P to be equal to the constant a, where a is a constant. And from this equation we are getting the value of q. Put the value of p over that. We have p minus q square equal to 0. Put the value of p over here to get the value of q. So q is equal to the square root of a, right? Now using the equation to find the complete integral, dz to be equal to not p dx, it is capital P. So right here p du plus q dv. In the previous example I have used here dw. Why? Because I have considered u to be equal to log x, v to be equal to log y, and w to be equal to log z. I have introduced this extra variable w also in the previous example. 3 variables we have considered. That is why we have to use dw to be equal to p du plus q dv. But here I have considered only the 2 variables, u to be x plus y and v to be xy, only 2 variables. So for that there is no need to write dw, just write dz only, right? For 3 variables we write here dw. Now putting the value of p over here, this is dz. What is p? It is a always, plus q is square root a dv. You can also consider q to be equal to a and get the value of p. You can also do like this, but I always take the only one way to consider p to be equal to small a, right? So now integrating, we get z equal to a u plus square root a v plus the constant b. And now putting all these values back, the values of u and v back to this equation. So z is equal to a into u. What is u? It is x plus y plus square root a into v. So square root a, what is v? It is product of x and y plus the constant b. B is a constant. So this is the required complete integral for the given equation. Alright, thank you.